Okay, welcome. Let's continue on with section 2.6, which is building mathematical models. And in this section, you will definitely want some sort of graphing utility, whether it's a graphing calculator or Desmos, but you're going to have to be able to graph these functions, and we will have to play with windows. Okay, so let's start off here. We've got a graph of y equals x squared minus 1. So let's go ahead and draw that. Again, a rough sketch is going to be fine. So it's a parabola that has shifted down by 1. So if it's shifted down, that means my y-intercept is at 0, -1. And we know our quadratic, if there's no stretches or compressions, if I step 1 to the right and go up by 1, I am on my function. And it's symmetrical, so here we go. Okay, and now it tells me, express let xy be a point on this graph. So on this graph of a parabola, pick any point. And I'm just going to pick this point right here, and we're going to call this xy. Not very original, but that is what we are going to call this point. Okay. It wants to know, express the distance d from point P to the origin. Oops. Okay, let's do a different color here. This is d. How am I going to write an equation for d? Well, I've got this triangle here. This leg is x, this leg is y, and we know from Pythagorean theorem we can build a right triangle. We can find the hypotenuse as a squared plus b squared equals c squared. In this case, one of my legs of the triangle is length x, so x squared plus the second leg of the right triangle, y squared, equals the hypotenuse squared. And I'm going to call this one d. D squared. Well, that's great. However, two things. It says express the distance d as a function of x. So I don't want any y's in here. To get rid of this y, I'm going to have to replace it with some other expression. Well, we were also told that this graph that this point is on, the equation of the graph is y equals x squared minus 1. So I have an equal expression for y. So I'm going to replace this in here. So I've got x squared plus, now I'm replacing y with x squared minus 1, and that whole thing has to be squared. That equals d squared. Okay, but I really want to know d as a function of x. So I've got to take the square root of both sides. So the square root of x squared plus x squared minus 1 squared, oops, went too far, equals d. And this is a function of x, so I'm going to put distance is a function of x, and it equals this. I would like to multiply this out, so you need to do FOIL or box, and we get x squared plus x to the 4th minus 2x squared, oops, 2x squared plus 1 equals d of x. And let's combine like terms here and put them in the proper order. So we have x to the square root of x to the 4th minus an x squared, because these two are similar terms, plus 1 equals d of x. So any distance on this parabola, I can calculate how far it is from the origin using this expression. So that was part A. Part B, we want to find out what is the distance if x is 0. So in other words, we're going to be putting a 0 into this equation. So when I do that, I get 0 to the 4th minus 0 squared plus 1. 0 minus 0 is 0 plus 1, square root of 1. And the square root of 1 is either positive or negative 1. We are only interested in the positive value because a distance is always a positive number. So part B is 1. And this makes sense. If x is 0, here's the point on that parabola. That is exactly 1 unit away from the origin. So it's a good sanity check there. Part C, what if x equals 1? So again, we're going to plug this in. So put a 1 in for x, and we're going to calculate. So 1 to the 4th minus 1 squared. And notice the minus is not getting squared. I will square the 1 and then subtract it, plus 1. Again, this gives me the square root of 1, which is just 1. Part D is asking, what if x is the square root of 2 over 2? Well, no problem, right? We can do this. Just plug it right in. So the square root of 2 over 2 to the fourth minus the square root of 2 over 2 squared plus 1. When we multiply this out, we multiply it times itself 4 times, and it's still under the square root. So this gives us the square root of 16 over positive 16 minus the square root of 4 over 4 plus 1. So hopefully we remember all these lovely rules. We've got square root of 16 is 4 over 16 minus 2 over 4 plus 1. Of course, we want to simplify this, so we've got 1/4 minus 1/2 plus 1. If we combine these, if we want to combine our like terms, which are all these numbers, I need a common denominator. 4 is going to be my common denominator. So I will have 1/4 minus 2/4 plus 4 over 4, which gives me the square root of 3 over 4. And when we're looking at a square root, we can separate the numerator and the denominator. So we'll have the square root of 3 divided by the square root of 4. And again, that gives us the positive square root of 3 over 2. That's just an equal sign there. So that is the distance when x equals square root of 2 over 2. And I don't know exactly where that is on this parabola, but it's somewhere on this parabola. Now the final part, part E, says use a graphing utility, so Desmos, a calculator, whatever you want, and we want to graph our function, not the parabola, but this function right here. So I'm going to put this into the calculator. Oops, and let's make sure I put it in the right calculator. So I've already got this entered for us. And what do we want to do? We want to locate where there is a minimum value. Okay, and we're only interested, it tells us we're only interested when x is greater than 0, because distance, well, it just wants us to look at that. So let's go ahead and take a look at the graph. There is our graph. I can zoom in a little bit, that would probably help. So zoom in. Let's see if we still can see it. And there is a faint, it goes down slightly and back up. I'm interested in the local minimum, so it's right in this area. So second trace minimum. And I've got to put the cursor to the left of the minimum I'm trying to find. So right there is great. Press enter. Now it wants the right boundary. So I've got to move the cursor to the right of the minimum and enter. And then I'm not guessing, so I'm just hitting enter. So my coordinate, rounded to 2 places, is 0.71. Let's write this over here. Oops, this is E. 0.71, and the value is 0.87. So what this says is the closest I can ever be to the origin is 0.87, and that is when the x value is 0.71. Okay? And let's go to another video to do example 2.